Welcome again. In this video I will solve question number 1.126 from the problems in general physics by IRODOV. Let's look at the problem. The problem says that a particle of mass m moves along a circle of radius r with a normal acceleration varying with time as omega n equals a t square, where a is a constant obviously. Find the time dependence of the power developed by all the forces acting on the particle and the mean value of this power averaged over the first t seconds after the beginning of motion. The key point is that the particle is moving along a circle of radius r and the normal acceleration is given. But in case of any particle moving along a circle, normal acceleration is same as the centripetal acceleration, as you know. Eurodov sir is very much clever. He might have used this terminology just to confuse you. In that case, uh, let's try to solve this question. This is the direction of centripetal acceleration as well as centripetal force or normal force, and this will be the direction of tangential force. As you know, v square r is the centripetal acceleration as given in the equation. Centripetal normal acceleration or the centripetal acceleration is a t square. From this data, finding the time dependence of velocity as now differentiating with both sides with respect to t, we will get, so this is nothing but the rate of change of velocity for a particle moving along a circle. The velocity vector always directs to the tangential at each point, so rate of change of velocity means some force is acting on the particle when it is moving along the circle, and the force directs in the direction of tangent to each point, so it will give the tangential acceleration, which is caused by some tangential force which is different from the normal force, and both forces are normal to each other. So the tangential force will be this one. So now we have to calculate the instantaneous power developed. Sorry, it is the acceleration. Mass time acceleration will give the force, so expression of force is tangential force. So the instantaneous power developed is dot product of velocity and force vector. So the force, as in the question it was given, uh, the independence of power developed by all the forces. So there are two forces acting on the particle, so one is directed towards the center and one is tangential. So but the one thing is that the normal force is normal to the velocity vector. The tangential force and the velocity vectors are directed towards the same direction, so the dot product of normal force and the velocity vector will be 0, so we can just simply write the tangential force here. So just write it, tangential force was normal force dot product into v, so dot product of these two terms will be 0, so remaining terms will be product. Let's omit the vector sign here in this place, cause velocity vectors and the tangential force are directed towards the same direction. So let's write it, mass time acceleration, that is the tangential force, and velocity vector. Velocity will be nothing but r a t, so m r a t. This is the expression for instantaneous power developed. So now we have to calculate the average power. Whatever time depends, and the mean value of power averaged over the first t seconds after the beginning of motion. So we will have to calculate the work done for the first t seconds, and then we will have to average it. You can note from the figure that the normal force is responsible for only the changing the direction of velocity vector, and it is always normal to the velocity vector. Suppose in this case also it will be normal to the velocity vector. This is the tangential force, sorry, normal force. So it does no work on the particle, so only the tangential force is responsible for doing work on the particle. And another thing is that at each point the tangential force and the velocity vectors are parallel to each other. So, and one other thing is that the tangential force is responsible for change of the velocity and for increase in length, or the distance covered. So we can write the simple kinematics relations for the velocity vector. I mean, writing it in one dimensional equation, and writing the simple kinetic relations like velocity at some time t is the initial velocity plus at, where a is the initial, I mean the tangential acceleration, and t is the times covered. So we can simply reduce this circular motion to a one-dimensional equation with the acceleration that is equal to tangential acceleration, where normal acceleration or the normal force is responsible for change in the direction of velocity vector, and it is not responsible for the change in magnitude of the velocity. So writing the simple kinetic relations as said, now calculating the distance covered for the first t seconds, it will be equal to ut plus half at square, where a is the tangential acceleration. Initial velocity was 0, so it will be just tangential acceleration was from this ra, half at square it was. Now calculating the work done. Work done is nothing but ds. Initial position was 0, final position will be s of t. And now you can see that each point the incremental change in the distance, that will be the ds, and the force are in the same direction, so it can be reduced to one dimension. So f ds 0 st. So the force was as force is constant, we can write it outside the integration sign, 0 st ds. So it will be just st. From here st is half times ra t square. Sorry, this half was not there. It will become mass ra t square divided by 2. So mean power will be total work done. Mean power will be total work done divided by total time spent. So total work done is mra t square divided by 2. Total time is t. So mean power will be mra t divided by 2. So this is the final solution. Thanks for watching, and follow my channel for more solutions to problems in general physics. Thank you.